Good morning, everybody. I hope you can all hear me for today's webinar. It's the last in the year from Cirrus Research, and today's topic is boundary noise monitoring, protecting projects, communities, and compliance. So welcome, everybody. I'll make a start on the slides in a second. Just to say a little bit about Cirrus Research and myself. My name's Craig Story. I'm a technical sales manager here at Cirrus Research. So I've been with the company about nearly 14 years, selling noise monitoring and related products for Cirrus. I do a lot of the training, the webinars. I get involved in some of the more consultative sales where we're putting out boundary noise monitoring for various projects and companies. So I've got a lot of experience in defining what's required, positioning, and things like that. So I've got a lot of experience there. For those of you who don't know Cirrus Research, it's a company that was founded in 1970. Our primary focus is noise measurement. So we've been going about 55 years now, and we sell globally all of our products through a huge list of distributors and resellers. Our main office is based in North Yorkshire. We also have an office in Germany and France. And we've been a sponsor of the Institute of Acoustics for many, many years as well. So we're right in the middle of the noise monitoring and noise measurement group, and hopefully you'll learn something interesting today. What we're going to be doing is going through a number of slides just to talk about boundary noise monitoring. And at the end, we should have a few minutes, maybe 30 minutes or so for questions. So what I'll do is I can see all of your questions as they're coming in. So please put them in the chat. And if I can answer them as I'm going along, I definitely will. Otherwise, we'll recap at the end and go through all the questions. This particular webinar, just like all the others, will be available on our website in a few days' time to look at. But also everybody that's either attended or has signed up to attend but maybe couldn't make it, you'll also get a link to this webinar so you can look back at it at your leisure. So I'll just, first of all, hopefully everybody can see the slides. I've just got somebody from Anthony saying, will you be sharing the slides? I'm hoping you can see a little picture of me in the bottom left-hand corner and the first slide. So that's good. But you will get to see all of the slides. And if somebody wants a copy of those slides, then you can contact me at Cirrus Research and I can send you those slides separately if you wish. So that's not a problem. Okay, let's make a start. Boundary noise monitoring, protecting communities, projects, and compliance. So basically what we're going to cover today is we're going to look at the importance of boundary noise monitoring in its entirety. And boundary noise monitoring is used for quite a number of different reasons. You've got the obvious ones where you have short-term or even long-term construction projects where you need to monitor the noise levels that you're making while you're doing a specific task or set of tasks. And then you've got the other side of boundary noise monitoring, which is sort of more permanent, long-term. And that could be anything from a standard industrial site through to a sporting arena or a mining area, open cast mining, or a racetrack or anything. So boundary noise monitoring really covers a wide range of different activities. So we're going to be looking at why it's important. We're going to be looking at some of the key compliance frameworks and in relation to planning requirements as well. We're going to have a little look at some of the best practices in measurement techniques, reporting on the information and people's response to that. And then finally, we're going to have a look at how some of the more modern monitoring tools make that sense of compliance a little bit easier and hopefully more reliable and much more effective in the future. And then, as I say, we've got a Q&A at the end. Okay, so first of all, we always look at why is noise measurement at all required? And a lot of these, particularly on the project side of things, where people are monitoring, say, for example, construction sites, it's not generally just noise measurement. It could be dust, it could be ground-borne vibration, it could be a few other things. But the purpose of today is just to focus mainly on noise. But at the appropriate point, what I'll do is I'll put in some comments about some of the other types of monitoring that you can go alongside this quite easily and seamlessly, to be honest. So noise is a major source of pollution. Now, it's in recent years, people have sort of coupled this along with sort of dust or particulates as a big concern. And the more research that is done on the effects of noise, the more people are understanding that it is a big health concern. And basically that's what that pollution means. It's an issue with your health. So it's not just, we're not talking about occupational noise where loud sounds will damage your hearing or something like that. That's not what we're talking about. We're talking about noise that provides an added layer of stress on people's everyday lives. And whenever you add stress into an equation, particularly with human health, you basically can get some adverse health outcomes as those stress factors play havoc with your body. So whether that's heart disease or mental health or a number of other things. So as time is going on, people are realizing more and more that making sure that noise is something that is controlled to reasonable levels is something that's very, very important. And of course, it has an impact on the local environment. I've not even touched on sort of impact on wildlife and nature. That's not really the point of today, but just to say that when we're talking about noise measurement, we're looking at the impact really on the local environment. So whether that's housing or schools or whatever. So it encompasses everything really. So it does bring health and potentially some social issues as well. It is quite heavily regulated, but maybe not as much as some people would like, or maybe some people think it's a little bit over-regulated, but it is regulated. It sort of comes under the auspices of the Environmental Protection Act 1990 and the Control of Pollution Act before that, 1974. And some of the aspects of this webinar today are really going to be focusing on maybe sort of construction, but we'll talk about standardized industrial sites as well. So one of the standards, and there are quite a few different things here that come into it, and we don't have time to go into all of them today, but one of them is either Section 60 or Section 61 related, generally speaking, to construction sites and demolition sites. And this is where you're either imposed upon you by the local council, which would be a Section 60, which is say you must not make more noise than this over these hours, and that's regulated, and you must demonstrate that you're not doing so. Or what most companies tend to do, which is put forward as Section 61, which says we're going to do this project, and these are our hours of work, and these are the noise levels, and this is the equipment we're going to use. This is the way the traffic's going to be managed, etc., etc., etc. It's a basic plan of what we're going to do while we undertake this particular project, and this is what we say we're going to make in terms of noise levels in this case. And then only if that is breached, generally speaking, would a Section 60 be imposed, but a Section 61 is something that that companies would put forward to say, right, this is what we're doing, and usually the local council would typically agree with that. One of the other key sort of British standards, particularly for construction and open sites, is BS 5228, which is a code of practice for noise and actually for vibration, which is really about understanding. You can use that standard to look at the activities that you're going to do on site and look at maybe what the typical noise levels are going to be, so you can then proactively manage the noise levels that your particular site or project is going to put out. So that's something that is quite important. So there are a lot of other things associated with this. As I say, I'm not looking to go through them all today. But one of the other things that you tend to get is where things are either council driven, license to operate driven, or the EA, the Environment Agency driven. So many councils do have their own construction code, particularly in London, that would help anybody that's due to make noise in their construction or demolition project. And a lot of these things typically would define, as I've mentioned earlier, the specific hours of working, and it will tend to prescribe regular monitoring of this. In typical sort of on-site and off-site levels would be an LEQ, which is an average noise level, basically of every 5 minutes, an average not exceeding 70 decibels on-site, and maybe 75 decibels on an hourly average off-site. And there are many variations of this. That's just some typical levels that people use. But of course, with the license to operate side of things, that's where the council will give permission, or it could be in the planning permission for a particular industrial site or entertainment site or whatever, and it could be part of the conditions that that particular site or location cannot make more than a certain amount of noise, whatever that happens to be, at particular periods of the day or days of the week, and that noise level is something that is it can be very specific, and it would usually put the onus on the owner or the occupier of that particular site to prove that they weren't breaching those licensing conditions. And in that way, they would have to typically monitor. And the reason that we monitor on the boundary, which is the title of this talk, is because in a way we're not particularly interested in how noisy it is inside a site, whether it's inside a factory or otherwise, because that's not the noise level that's affecting the community. Now, in some rare cases, then you might need to monitor in the community itself, which I've seen that. We've got some of our equipment there, which is doing that for certain companies. So you might need to monitor in the community, so near to housing, for example. But generally speaking, what happens is we tend to put these noise monitors on the boundary, which means on the fence line of a particular construction project or industrial site. And the reason for that is that we're interested in what's leaving the site, which is then going to travel towards that community. So it tends to be in line with the housing and the noisiest part of that site. So it could mean any site has just a single monitor, or it could be multiple monitors depending on the size and the layout and the location, the topography of the site and the housing and everything else that's around it. So it could be many monitors, but typically they're on the boundary. And the reason they're on the boundary, as I say, is because we're interested in what's leaving the site. Now, you know that the noise levels that get to the people that would be affected by that noise is going to be lower by the time it gets to that housing, because obviously sound dissipates with distance from the source. But of course, a lot of these noise monitoring plans that are put in place will have had done some sort of modeling or some sort of work which says, right, we know that if the noise level is such and such at this point, by the time it gets to the housing, it will have dissipated by X amount. So you know what the levels need to be on the boundary, and that's where these levels typically are set for. So the noise level, let's say it was 65 decibels on the boundary, averaged over an hour, say. By the time it gets to the housing, it could be much less, but it's been worked backwards to give you those sort of ideas. And it could be, of course, that it's the council themselves or the local authority or the Environment Agency will set what those limits are. They may even define exactly where you need to measure or assist you in that. But it's this combination. So boundary noise monitoring is really good. The other reason why doing it on the boundary is good on the fence line is because you can put these monitors inside or on your own property. So what that means is you've got control over that device. Nobody's going to be able to interfere with it. You've got full control over the power and the comms and everything else that goes with it. So where you've got monitors that are at another on for example, in a housing estate or on a lamppost or in a local substation area or something like that, you've got much less control over that. So that's why we're doing it. Now let's have a little look at what typically can cause noise just quickly. Obviously you've got lots of heavy machinery and particularly things on site. If you've got general noise from an industrial site or industrial complex, you've got things like fans, various machinery that comes on and off. There are potentially lots of things that can cause high noise levels that might potentially be disruptive to the local population. And one of the other things that comes up quite often is the fact that you've got a lot of traffic associated with sites. Construction site, obviously, as the picture shows, lots of noisy machinery, transporting goods and materials, etc. And maybe doing some servicing works on roads and things like this. Quite noisy. But you've also got a lot of traffic potentially associated with static industrial sites. So, even supermarkets and things like this. So it could be limited by the times of day that traffic's allowed. You could have to put a traffic management plan in place, which takes effect not only of the impact on the local roads, but also the times of day that those noise levels are going to be higher because of that increased traffic. And you've also got the workers themselves, mobile phones, radios, etc., etc. Forklift trucks actually used to be a big one. That I think they still are in certain locations. They tend to use a different sort of sound these days to mitigate that a bit. So it's not the high-pitched sort of beeping sound. It's more of a white noise sort of sound. But so there are improvements as time goes on. But any sort of movement of machinery or of vehicles on site could potentially cause an issue. So one of the things that you have to do once all of this is in place, that you've got an agreement. So yes, you can operate your project or you can operate your site, but you must keep to some agreed limits. And there are various mitigation measures that companies can use to actually help with that. Because of course, at the end of the day, the noise monitoring, the boundary noise monitoring is really a last resort. That's not going to cause the noise levels to be any quieter. It will let you know what those noise levels are. You can use that data to put in an improvement program or to look at individual complaints and work out what is causing an issue and fix it much quicker. So there's lots of advantages to it. But obviously, like with anything, with a hierarchy of control sort of concept, really you're looking at trying to reduce the noise that's been generated at its source. So lots of mitigation measures that you can use. Obviously, your different methods of working. What equipment are you using? Can you use things that are quieter than others? Fabricating a lot of equipment off-site and bringing it on-site, so you're not got all, you're minimizing the amount of sort of metal bashing and things that you're having to do on-site. Keeping the noisy plant areas, if you've got any sort of crushing equipment or something like that, away from the public areas. Put it in an area of the site which is far away from the boundaries possible. Only do noisy activities, for example, at certain times of the day. There will be, particularly with construction projects, obviously piling and things like this, which are noisy, fairly time limited, but they have to happen for that particular project to move forward. So that's something that you can specify to the local population around about what you're going to be doing as well. So it's about communication as well to the local community, just to keep them informed, to say, right, we're going to do something noisy here at this particular time. And of course, you've got those boundary noise monitors to keep an eye on what's actually leaking out into the local environment. Delivery times can be adjusted, as I mentioned earlier, to do with traffic management. So you're not having things delivered to site or taking away from your site at 3 o'clock in the morning, 4 o'clock in the morning. You've got sort of limits as to what happens. That's one of the big complaints that when talking to our customers that we see, people say, well, I've had a complaint last week and somebody said they saw some lorries going in delivering some goods at 5 o'clock in the morning, and we're not allowed to do that until 7 o'clock in the morning. So you can use the system that you've got to show that actually no, the noise wasn't from us at that time of day, because you'll have all the records on the side, as many records as you like, but unless you've got some sort of proof as to what those noise levels were and some idea of where that noise is coming from, then people just won't believe you. So having that information is a really big help, and sort of varying the routes of vehicles as well. So the key to all of this, as I'm sure you've guessed, is to make sure you're keeping to your agreements, which is what all of this is about, is measurement. And one other thing I would say is that not all sites that have boundary noise monitoring today are doing it because somebody has told them to do it. The good companies, the ones that are really environmentally proactive, if they realize they've had a problem, they might have had 1 or 2 complaints, it might have been isolated, but they know, because they might have done some initial sort of measurement work, they know just to be a good neighbor, they want to put a noise measurement system in, a boundary noise measurement, maybe just 1 or maybe 2 or something like that, but just to give them that peace of mind that they're being that good neighbor to the local population, and it's something that they plan to do. So it's not always forced. It's something that the good companies actually, if they think they've potentially got an issue, or they might know that they've got a piece of work coming up, maybe an extension, they're building a new piece of the factory, an add-on or whatever it happens to be, that's something that they would actually put in place ahead of time, just to capture it and just to be on top form. Just a reminder, if anybody's got any questions, just please put them in the chat, and hopefully we'll get to them at the end. So some typical noise levels for construction sites here, just to give you an idea of what those noise levels are. Now, some of them are fairly quiet, normal conversations about 60 decibels, but when you start getting sort of grinders and cutters and pile drivers and hammers and things like this is where you start to get way above the 80 decibels, 90, 100 decibels. So some of these things are pretty loud. Now, it's only that loud, it's only that many decibels in that locality. But once you start getting noise levels start to rise, then they are, as we know about decibels, they're logarithmic in nature. So 90 decibels is 10 times louder than 80. 100 decibels is 100 times louder than 80. If you get up to 110 decibels, that's 1,000 times louder than 80 decibels. So this is the way noise goes. And a lot of it depends, and you can't just say, well, if it's 100 decibels here, then it's going to be 50 decibels a mile away or something like that. It doesn't always work like that. It depends on the ground that's in between this, what they call the source and the receiver. And it depends on the topography, any buildings in the way, a whole lot of other things. But just to give you an idea of the types of equipment that can be very noisy. I've just had a comment from Simon. Thank you very much, Simon. He says, Craig, we find boundary noise. This falls into our social value TOMS framework, TOMS framework. It's also driven by customer demands. So yeah, I think that he's basically saying that it's something that, as a company, then they take very seriously, which is good to hear. So what is boundary noise measurement then? Let's get into a little bit of the detail. So as I said, it's a method of capturing what those noise levels are when you're exiting the site. And it's a way of measuring the impact of your company, whether it's an industrial site or an entertainment site or a construction site, whatever it happens to be, on the local community. We typically put it on the closest point to the receptors we can get on the boundary. It's not always possible because of fencing and things like this and power and etc. But there'll always be a way to get it somewhere close. If you've got a large site and you've got a housing estate on the north side, there's no point putting your only boundary noise measurement device on the southern end of the site, where all the impact, even though that might be the loudest part, where all the impact is to the north, where that housing estate is. So it's got to be sort of in line at the closest point to those receptors. You've got an option with these systems basically to do timed or continuous recording. So even though we're talking about boundary noise measurement, what I'm going to be suggesting is a continuous measurement, which means permanent, sort of fixed or semi-permanent systems. That's not always necessary. Sometimes, so the timed aspect of this is where you might actually monitor this with just a handheld sound level meter of some description. So you'll go out there and take measurements on a regular basis. So you're sending someone out there to the boundary, to the appropriate location, and you might measure for an hour or even 30 minutes or whatever. And you might do that on a regular basis and report your results. So you don't necessarily have to go the whole hog, if you like, and go for that fixed permanent monitoring. You can do it on a time basis. So that's basically looking at it on a scheduled basis, going out to see what those noise levels actually are. And it might be that if you're in contact with the local council or whoever's sort of authorising that work, that may be something that they will agree to. They may not. They might say, no, you've got to monitor it. They may leave it up to you to decide what's the best course of action. So this may be necessary, for example, as I've put there as part of a Section 61 agreement, if it typically was a construction site. So this is what we're trying to do. We're trying to measure the noise level at the outer part of the site to see what's affecting your neighbourhood. So what sort of equipment's available? And this is this next section. What's equipment's available? What should we be capturing? And then, of course, what do you want to do with the data? Because with noise measurement systems, modern ones, you have such a huge amount of potential data that you can collect. But of course, it's important just to understand what part of that data or what is important, and what other tools are available to actually supplement the noise data to give you a better idea of what's going on. So let's have a little look. So typically, just as a first thought, when we're looking at measurement equipment, it needs to meet, generally speaking, a certain standard. So, you could go out with your phone. You can get a decibel meter app on your phone and do that. And if you're comparing maybe one day with the next on a phone, that will maybe give you some idea. But if you're looking at what the absolute noise level is to a specific level of accuracy, just using your phone will not cut it. Because the instrumentation needs to meet a very specific standard. So whether that standard comes from the BS 5228, sort of construction noise standard, or BS 442 or whatever. So there's a whole different sets of standards. Typically, they look for some instrumentation to meet a very specific standard. And you either use, typically it needs to be a type or a class 1 instrument. So it's a higher level of accuracy. And it needs to meet a 61672 standard for the sound level meter or the noise monitor itself. And that defines how it's actually working to capture that noise level. So you can guarantee if somebody comes to you and says, well, you were too noisy last week, and you say, no, we weren't. I've got the data here. It shows us that the noise leaving the site on the boundary noise monitor was below this level. And they'll say, well, what are you using? And you need to be able to show that the equipment meets various standards, got a certain level of accuracy. So it's important that that the equipment that you've got reflects that. So what I'm saying is, just using a mobile phone app, whilst indicative, it's either high noise or low noise, is not accurate enough to do this job. So there's typically two sets of equipment. This is the sort of Cirrus Research options here. We've got other options as well. But one of the two main differences are using a handheld sound level meter, which is that picture on the left there. And that's nice and portable. It's something where you can go to a number of different locations. It's basically got batteries in it. It's a tended operation, so somebody has to be there with it. And you either put that on a tripod or just hold it in your hand and take a measurement in a location for a specific period of time. It could be typically 15 minutes every hour, or do it for 15 minutes every 2 hours, or 30 minutes every, whatever it happens to be. But that's sort of attended measurements. Now, the advantage of attended measurements, of course, is that you can see what's going on if the site is small enough to enable you to do so. So you can maybe tie certain noise levels that you see on the machine with the activity that's on the site. So that's an advantage of it. But of course, you're not there all the time. You're only there typically for relatively short periods of time to get some samples, because it's expensive. You know, you're basically employing somebody to do that job. And then the other side of the coin is sort of fixed or semi-fixed systems, which is the picture on the right. So that's one of our quantum outdoor noise monitors. It just happened, that one happens to have a weather station attached to it. And that is a more permanent option. Now, these things can be moved, obviously, but that type of solar system would sit on a fence line, on a post or a tripod inside your boundary, or actually on the boundary fence. And that sort of system would operate 24/7. Now, what that means is you may, you know, in an industrial setting where you've got companies that work 24/7, obviously that's ideal. You can monitor it permanently. Construction sites that tend to finish maybe 6 o'clock at night, something like that, it might not be as useful, but of course it's there all day and all night. It's going to monitor when people start in the morning and they start coming in, so it's going to monitor permanently. The data is always available with that type of system, but it is unattended. So I suppose the slight disadvantage to that is, yes, you've got noise levels, yes, you've got a trend, you can see what it's doing. If somebody sends a complaint in and they say, well, at 3 o'clock in the morning last Friday, we were woken up because there's a really high noise level, I think it was you, you can then go back to that exact moment in time and see whether it really was you that caused that high noise level. Because sometimes you need a little bit of extra help with it. So there are systems available which not just have the fixed noise monitor there, but also will record the sound itself. Now, yes, you can do that on the handheld unit, but being able to record the actual audio is a really good way of understanding what causes these high noise levels. Now, you don't want it logging the audio permanently, because you'll just have too much to listen to and it takes up a lot of space, etc., etc. But what you can do with these systems is you can set some trigger levels. So the idea is, if you know what the limits are supposed to be in a particular location, you can say, well, if it goes close to that limit or over that limit for a certain length of time, then record the actual sound itself. So you've not only got the decibel levels, which you could look at and say, yeah, well, oh gosh, we were loud, but you can also listen back to what was happening at the time and have an understanding of, well, was that a police helicopter overhead? Because you'll hear that and you'll understand it. Or can you hear one of your dumper trucks going along the road? You know, you'll be able to get a much better understanding of what was causing that noise level. And that's one of the ways that you can actually define whether it's coming from your site or not, by listening back to what those high noise levels actually were and get a determination. Now, sometimes you can't always, even if you hear it, you might not understand whether it was you or not. So what some people do is they have, say, maybe an extra noise monitor internally on the site, which will give them an idea of what the internal noise levels of the site are, next to maybe the noisiest piece of equipment. So if you've got a high noise level at the boundary and you've got a high noise level in the site, you'll know it's coming from you, or vice versa. If it's high noise level on the boundary and it's a quiet noise level in the site, it's coming from elsewhere. That's one way of doing it. But the other way is, some of these systems, like our quantum system, you can actually have a camera attached to it. So when that trigger goes off, not only is it recording the sound itself so you can listen back to it, but you can also have that camera taking some pictures or some video as well. So it's basically a CCTV camera that's specifically related to that particular noise monitor. So, yeah, thank you, Gemma, for your comment on that. But yeah, so having that CCTV camera, the camera doesn't necessarily need to be located where the noise monitor is. It could be at a distance, of course, because that could be pointing at a roadway or at some stacks or something, so you can actually see what was happening on the site at the same time the noise level was getting high. So that's the other thing you can do. So there's various ways you can do to get around that. The simpler systems, of course, are just the noise level, and you've got that permanent trace of what it was doing at each point in time. But you can add things in like recording the sound and potentially a camera, so you can really understand what's causing the issues. So you can go ahead and fix them. Or even if you're clever and you set those levels appropriately for those triggers, you can maybe actually prevent them getting to be an issue in the first place. So, but it all depends on your site and how that works. So what are we actually measuring? Just to give you an idea of the sort of things that we're talking about with this sort of system. So the key one is this first terminology at the top called LAEQ. L just means a sound level. EQ means an average, and because decibels are logarithmic, it's a logarithmic average, but an average nevertheless. And A is, and you'll see that in the one below that it stands for A weighting. It's a frequency weighting. Basically means the system is logging the data in the way that humans hear it. So it's logging it at the level that humans actually hear it, not what's really there, because you probably know this, but humans are not the best at understanding noise levels, particularly if there's a lot of low frequency noise there. We just don't hear it very well. So it's a standardized way of giving you a number or a set of numbers that relate to the way we actually hear the sound. So this LAQ is an average noise level over a period of time. That's typically one of the things that we look at. So it could be daily, it could be an hourly average, it could be a work time average, it could be just a 5-minute average or something like that. It all depends on the circumstances. Because this is such a general talk, we're talking everything, as I mentioned, from racetracks, entertainment venues, to petrochemical plants, mining, construction sites, etc. So it all depends on what's actually required. But that's the first thing, is basically an average. Because that's typically, and why we do that, it's typically because that's the way if there are any limits that are set, that it's typically set that way. And the other thing that's typically put forward is the maximum sound level. And that's got an extra letter in there just to complicate matters, because we don't like making measuring noise easy. It's got an F stands for fast time constant, but it's basically a maximum noise level. So in any period of time, it's looking to see what the maximum noise level is. And sometimes limits are set on that. So you can say, well, I want the average less than this, but the maximum noise you can make based on where you measure it could be no more than that. Again, it could be a daily max, an hourly max. So there's a couple of different things that tend to go in there. Typically, it's the average noise level more than anything else that's used. And then you've got a couple of other things that are not measured, but that data is used to give you things like the lowest observed adverse effect level, and then the significant observed adverse effect. So this is to help set what those levels are. Basically you want to be able to affect the local population as little as possible. There's a question there from Jensen. Thank you very much. He's asked, or she has asked, would LA10 and LA90 useful to record during boundary noise monitoring? What those are, I haven't got a particular slide on that, but one of the things that people do before they actually start a construction site, or let's say you want to add an extra wing to your factory, they want to know what the background noise level is. So what is the typical noise level in an area before something is changed or starts? And one of the ways you can do that is look at the background noise level. And the typical parameter that we use for this is something called a statistical level called an L90 or an LA90. and typically these systems will measure that for you, and most of them will record that information, so you can have that background noise level. Because what we're interested in is, if this wasn't there, how much of an effect are we having above the background noise level? And just to complicate this even further, of course, we know that it's not just the level of sound that's an issue sometimes, it's actually the quality of the type of sound it is. So, you can actually put in numbers when you're determining what these levels should be, that you shouldn't be breaching, based on the quality of the noise, rather than just the noise level itself. So it's a complicated subject, but there we go. So there will be limits, basically, that I said. And again, as I said, it could be a Section 61 agreement that you put in place as a company, or it could be license to operate, or council defined, or even internally done within your company. If you haven't had anything specific or any assistance from the local authorities, you can actually do that yourself, just to make sure that you're being a good neighbour. Okay, so equipment and placement is the next bit. I've mentioned the boundary, and the boundary can be a number of different things. It could be a solid wall, it could be a fence, it could be an open area of land. But whatever we do and wherever we put it, the correct equipment is key to this. So I'm assuming here that we're not just going for the handheld sound level meter, we're going for more of a fixed or permanent noise monitor. That picture there shows you a noise monitor on a fence. It's a fairly temporary system with a sound level meter in that box at the bottom, that black box, if you can see it, and we've got a microphone on the top. So that type of system is sort of more of a, I call semi-permanent. So that will have its own batteries in there, and you can maybe move it around as your construction project moves, as an example. But any equipment you do have, you just need to make sure it's reliable, it's flexible enough for your needs, and it has all the data. Now, most of these sort of environmental noise monitoring systems will definitely have all the data, but it's something you will need to check when you start to look at it. Whatever system you put in, a fixed system, it's got to be free field. So that microphone is key. That's what's picking up the noise. You don't want it under trees. You don't want it in a corner. You want to make sure that it is open, so that any noise leaving that area past that fence, it's going to pick it up. The next thing you need to look at is its height. Basically, it needs to be at least 1.2 to 1.5 meters off the ground, so you're not getting any noise reflections off the ground surface. But depending on what ultimate height you put it at, it really depends where the noise is coming from and where the receptors are. So, typically on a 6-foot fence, just poking up above, fine. But if, you could be in a valley and the housing that you're affecting is up a hill, so you may want to increase the height of that to get a more realistic way of capturing what noise is coming from the site and going up to the housing, for example. I said before, it's usually aligned with the nearest receptors. So it's in line with it as near as you can get it with the receptor and the noisiest part of your site, whatever that happens to be. That's the specific standard there for the sound level meter stroke noise monitor that you want to put in. So it needs to conform with that particular standard. And if it doesn't, then I would seriously question why that's there. And preferably, I would always say it needs to be a class 1 or a type 1 instrument. That means it's much more accurate across that wide range of frequencies that these meters actually measure. But yeah, that's what I would recommend. But placement is key, because you also want to be able to gain access to it at certain times as well. So you need to make sure that it can be accessed. But any system like that that's going to be more permanent, then you've got to think of a few different things. So, to think about power, it needs some form of power. Can you get power to it? Well, mains power, does it need to be solar power? Can it operate on batteries for a long period of time? If you've got batteries, that's great. It might last a few weeks, but you might have to keep sending people out to recharge the batteries. So that's something else. Make sure you've got a weatherproof system. So that's maybe that's not a very good image to put up after the news from Jamaica in the last 24 hours, but you know what I mean. It's got to be something that's robust and doesn't cope with 4 seasons in a day that we get from the UK. Generally, these fixed systems, you want to communicate with them. That's something else to consider. So yes, you could leave it there and you could wander up to it every week and download the data. That's one way of doing it. But ideally, what you really want to do is to have it permanently operating and permanently sending that data to you. So it's available 24/7. So communications is something that you need to look at with any of these systems. That's the ideal. It's not absolutely vital. As long as it's measuring, that's great. But you need to get information from that, particularly if you've put in some triggers. So if you put some triggers in that you want to be warned of when high noise levels exist, it needs communication to do that. With temporary sites, as you saw earlier, that earlier picture where you've got some sort of temporary fencing, people will steal these things. We have a lot of noise consultants, acoustic consultants using our equipment, and every now and again we get a call saying, oh, the equipment's been stolen. What people think they can do with this equipment, I do not know, because it's very, very specialized, but it isn't cheap. So maybe that's what they're doing, selling it on eBay or whatever. So can it be chained? Is it secure? And obviously, if you've got a site that's progressing, maybe it's a road construction project or something like that, can it be moved as the work progresses to different locations, just to give you a little bit of flexibility. Some of the other things that we need to consider then, I've mentioned alarms just now. So alarms is where you may want to be warned, or a particular set of people might need to be alerted when certain noise conditions occur. So you've got your monitor on the boundary fence, you know what the limits are, but you also want to be proactive with a system like this. So what you want to be able to do is to say things like, if the noise level gets above a certain point for a certain length of time, then send a text or an email or a notification to a particular person or group of people to make them aware. There are various screens and things of these systems the way you can see things pop up, but having that sort of alert messages can be quite useful. So that's about alarming. You may just want the system to note every time when a certain condition has occurred. You might not want to physically warn somebody, but you might want the system to mark up, if you like, when certain conditions occur, so that you can go back to it and analyze the data a bit further. Reporting is important. This is just a typical report. It's sort of a day, evening, night report. You want any system that you've got to be able to give you the information in a form that you can use, or maybe even present, because some of these systems you need to be able to prove that you're not breaching any licensing conditions, for example. So you want the information in a form that you can actually go and do that in an easy way. Accuracy of the data, we've already mentioned that. It's not just the fact that you're using the correct system and meets a certain standard and it's a certain class or type, but also that it is calibrated correctly, so it's not slipping over time. So you need to make sure that any system allows you to calibrate it on a regular basis, whether that's automatically or with a calibration device, and so you can prove that yes, this system is the right type of system, but it's also accurate as well. And making sure sometimes you need that data visible to not just the people that are on site, but you may want to make that data visible to the local community as well. So that's another option to consider. So just to go on a little bit on alarming then, so this is just what I mentioned. There's sort of typical from our sort of quantum system where we've had a number of breaches there. We've got what's called an event viewer. You can see where those breaches have occurred, and that's based on a certain set of triggers. And you can see there on the right-hand side all the information that's available to you for each of those breaches. So you can see how the noise level rose and fell. You can see what the frequency components of the sound was, if that may be important to you at the time that that event occurred. So if you, basically this section is just saying, look, you can actually, you can set those levels in such a way that you can be warned before it gets too late. So you can actually take some preventative action on it. Systems need to be able to report. The reporting is important, but the reporting does vary quite considerably. You will have a vast amount of data in on your system. So having something where you can just pull out the information that's required is important. You may have to do a little bit of manual work on it. But remember, typically these systems are logging those noise levels every single second. You can look at it that way, but really you want some sort of summary of that information, which makes it a lot easier to go back further in time to see, why is it so much noisier this week than it was last week, type of thing. So reports, you might want weekly reports, you might want monthly reports, and what you are reporting on may relate directly to what those licensing conditions are, but you might just want to list what the average noise level was, what the maximum noise level was, maybe on an hourly basis, and any list of breaches as well. So you want systems where you can pull that information out quite easily. So it could be that summarized data is all that's required. It may be nobody wants to see that information at all, unless somebody starts to complain a lot, or people will want to dive into that in a lot more detail. So it's important to establish what those reporting requirements are at an early stage, particularly on a project, but also if you're selecting such a system for your existing industrial site, understanding what information you do need to report on could go a long way sometimes to defining what system you eventually install. So reporting is important. We've mentioned the accuracy of the data. Typically, this noise measurement equipment will come if you purchase it with a calibration certificate. So it's been tested to say it meets that relevant standard. So it's not just built to the standard, but it's been tested and it's accurate. But what you can do is field calibrate that equipment, particularly on a handheld sound level meter, which is just that top image there. That's a sound level meter with that tube thing on. That tube thing is an acoustic calibrator. So if you pop that on the end, it's got a very specific noise level, a very very specific frequency to test your unit. Typically, if you're using a handheld unit, then you would what's called field calibrate before you use it, and then at the end when you've finished using it, just to make sure that it's still accurate, and then that all of the results you've taken in between are okay. With fixed systems, self-checking is something that a lot of these systems can do, which is really good. So it can actually self-check itself on a regular basis, but still putting one of those field calibrators on it on a regular basis every 2 or 3 months is important to do that. And that's called an acoustic calibration. So plan to do that regularly. Data visibility is the next one I want to briefly talk about, and this is where if you want to make that information visible to not just multiple members of your team on site, but also to maybe people off site. So some projects make that data available to the council or even to the general public. They may have their own website to do that. So it could be that any noise measurement system you put in, if it's more of a fixed system, you might want to pull that data out automatically into your own website and make that data visible. Or with the system, we have the quantum system, you can actually make specific pages visible to the wider general public. If you need to, you could create a secure URL link where they can just see that page. If you want to make that page just have the information on there that they need. So that's a way of building trust. I know some of our customers do that with with their own website, and they put that information up there, make it available. And it may just be to the general public, or it could be to the environmental health department in a local council. It all depends. It's not always done, but if you need to, then that's something to think about when you're defining what system you're going to go for. And then some further considerations then. So, if you've got long-term sites, that might define the type of boundary system that you put in place. If it's only a short-term project, then maybe handhelds would do. Keep checking on the system verification or the calibration side, and that's just something you need to bear in mind, because most of these systems will need this verification or full calibration, for want of a better term, on an annual basis. So you may either send the equipment away or maybe get somebody out to site to do it on site. Sometimes you're managing multiple sites, so you've got lots of systems everywhere. Does that define what sort of system you put in place? These systems do need managing, because if you're deciding to make the leap and to the expense of putting in a monitoring system, just make sure that somebody has got some responsibility for it and is managing it. Whether that's the manufacturer helping out, or whether you've got specific people on site to make sure that that system is up and running and you don't have any issues with it. They're typically very reliable, but you will get things occur. It's always better to understand when things are going wrong than just wait 3 weeks and say, oh, we've missed all that data. What have we got to do now? So whether that's internally, whether you use an external consultant to do that for you, etc. Then you might want to think about, is there anything else we need to measure? And I mentioned briefly dust, ground bore vibration, but one thing that is critical sometimes is weather. So having a system that gives you weather data as well is quite key here. Then, because weather can have a big effect. Sometimes, for example, sort of racetracks and things like this, if it's wet, you're going to get more noise. So you might need to know what the weather's doing. The direction of the wind and the strength of the wind, it can be an issue. Depending on which direction it's coming from, you might have more of an effect of the noise levels on your site, on the local community, than if the wind was moving in a different direction. And with any sort of system, if the wind speed is generally above about 6 meters per second, you're going to get wind noise to a certain extent. The higher the wind speed, the higher the wind noise. So above a certain wind speed, you may want to disregard. So it doesn't matter how noisy your site is or quiet your site is, your measurement system will be logging a higher noise level than usual because of the wind. So having some sort of a weather station put in there is alongside your noise data can be very useful sometimes, because you'll get complaints, but you won't be able to tell what was happening just by the decibel level alone if you've got high wind speeds. So take account of whether you need to add in these other systems to your boundary noise measurements as well. Okay, so I've talked for about an hour. I'll leave it at that. I hope I've covered everything that people were expecting. You can contact me directly at Cirrus Research. It's just craig.story@cirrusresearch.com, or you can go to sales@cirrusresearch.com, or go on our website and ask some questions. But what I wanted to do now for the next few minutes is go through some of the questions that we've had in. Thank you very much. And let me just go back through some of these and we'll have a look at them. Oops. And I'm just attempting to go on here. Bear with me. So one of the typical questions we get, I think this is Jonathan that mentioned this early on, was how our noise monitors, you're picking up noise, and you're picking up noise from everywhere. So it's typically, you can get directional systems, quite expensive, but they are there. Typically, it's getting, wherever the noise is, 360 degrees around the microphone of that noise monitor is picking up. How do you know it's coming from your side? Is basically the question. I think Jonathan mentioned this. So just to go over that, the decibel levels tell you how loud it is at that noise monitor. it doesn't tell you where that's coming from. So it could be the police helicopter, it could be kids shouting. Bonfire night's a typical one, so you see lots of loud noises on these noise monitors. So having the audio there captured on a system is quite critical. So you can listen back to it, and I would say 8 times out of 10 you'll have a good idea of where that noise is coming from. If it's from your factory or your workplace, you'll be able, your site, your machinery, that will give you a clue. The other addition, as I mentioned earlier, was a camera. So when these triggers go off, because it's a high noise level, you can get some images or some video, and if that's pointing in a typical direction there, you think your issues generally lie, then that's one way of again having that extra information so you can understand where the issue is. Jensen, I think I already talked about this. The statistical levels, L90, very good for background noise monitoring. Typically, these systems will always have that. So Stephen says, further to Jonathan's question, what are the key challenges in monitoring noise at site boundaries, especially in urban or mixed-use areas? I guess I'm thinking in terms of ensuring the noise is coming from a particular location or activity or business. It is very difficult if you've got lots of businesses close to each other, and you're not sure which one is, which one is got deliveries at 6 o'clock in the morning. I think the camera is probably the best way. In addition to that, in addition to the actual audio itself, and listening to that audio won't always tell you, if a truck's pulled up on next door or the truck's pulled up on your property, which is which. Who knows? Maybe the camera is probably a better way of doing that. So I think that's probably the best advice I can give there. Allowing for road noise, that was sort of Brian's question. And the thing is, you're always going to get a certain level of road noise. And this is maybe sometimes where these understanding what the background noise level at certain times of the day, if your factory or industrial unit is not there, might give you a good idea of sort of factoring in what the noise level of the roads is. Road noise is a plus and a minus in these circumstances. Sometimes if you've got a really constant amount of road noise there, then the background noise level typically for that area will be that much higher. So any noise you would have to make to annoy your neighbours is going to be so much above that. But always having that audio, I think, is key in determining what extra noise you're taking. Any road noise, any local background noise, not just roads, will be taken into account, generally speaking, when the noise levels are set, if you have to set some specific limits based on a license to operate or something like that. Mark mentioned another key to reliable measurement, which is a bugbear of mine, is the need to cross-reference sound levels with a reliable, accurate record of local weather conditions. If you rely just on the Met Office, things like that, then that their station that you're taking that data from could be some distance away as well. So having a local weather station as part of the mix, obviously, it could be a game changer there. So let's have a look. A few more questions here. Somebody's mentioned about traffic noise. I'm just reading them down. When somebody's done a background noise measurements beforehand, that road noise will have been taken into account. We're not saying this is easy, where you've got sort of condensed sites, lots of road noise and anything else. Picking out the issues at your particular site, if they are real issues, is not always an easy thing to fix. Getting in maybe some acoustic consultants is a start to that. There may have been some prior work done on that anyway, but getting some helpful advice from some experts like that would really, really help. Right. Next question. Joel made a comment, as you've probably seen, that post-filtering of vehicle pass-by events and things like this. Yeah, you can do that with this sort of data. You'll have that enough data to be able to post-process it. Typically, not everybody has got the time and the energy to do that. So, a careful sighting of your noise monitors is key to sort of minimize those effects, is what I would say. But Richard also pointed out, I think the noise levels to better the site boundary tend to be likely to be much higher than the background noise level. So, you're less likely to have those road noises as an effect. But of course, what happens is, you do get sirens and things like this, which could temporarily raise those noise levels. But that's you have to take that into account. Let's have a little look. Okay. What about nighttime noise from industrial site? New housing development being built close to the site, concerns raised. What is the best practice for measuring, bearing in mind the area at night is very quiet? I'm assuming, sort of, this is Barry's question. What Barry's meaning is that, if your industrial site is creating noise, maybe 24/7, or maybe there's some specific activity on a night time, you will have an issue with the housing development. That tends to be what happens is, as we know that just because your factory's been there making the same sort of noise level for 50 years, the fact that somebody builds a housing estate right next to it, that will have an impact on them. And you say, well, I'm not doing anything different. If the planning has gone through properly, then they may need to mitigate against noise from existing buildings or factories in maybe extra double glazing or the angle of the properties and things like this. But that does mean though you may end up with some issues in the future that you never had before. But the best practice for measuring is really, it's all about just sort of consistency. Having systems that are permanent, you can take account of the different conditions and what's been going, what the factory was doing or the industrial site's been doing at the time. Just doing a one-off measurement doesn't always give you that sort of information to understand what the impact is. But that permanent noise monitoring will do, because it's doing it night after night after night. Yeah, somebody's also mentioned increased noise flow due to rain and high winds. Absolutely. I've seen people put noise monitors directly under canopies of trees, which is not a good idea, because you get all the water dripping off and the trees blowing, and that can mask the sound quite a bit. Right, thank you for your comment, Paul. Yeah, so somebody mentioned the BS 4142 assessment. So procedure outlined in that standard. Thank you, Benjamin. This is true, and it's something that this is typically done before there's new additions to industrial sites, or it's a new build or something like that. And that's where background noise levels and specific noise and things like this are all taken into account. That being said, 9 times out of 10 people get away with building something, and you do not need the noise monitoring. The boundary noise monitoring is only needed really in exceptional circumstances where you've had a lot of complaints, or maybe the way the factory turned out was not what was anticipated, and you need to monitor. Or it might be you're in such a sensitive area that you've been asked to monitor those noise levels consistently to make sure that there aren't any complaints. But that's something that's done beforehand. Let's have a look. Yeah, somebody mentioned hearing protection, which is really good. But obviously, boundary noise monitoring isn't really going to help you with that, of course, as we know. But there are other things that, if you want to measure occupational noise, then you can monitor the people with noise dosimeters. You can use that handheld sound level meter to monitor workplace areas to monitor that as well. Anthony has got a question at the end here. When measuring concrete breakout in a courtyard surrounded by residential properties, where best to set up a fixed measurement as concerned with reflection? Yeah, that's an interesting question. So reflections come from the floor, could come from walls, etc. So if you're in a courtyard, I'm assuming it's sort of walled on most sides. You don't want to put the measurement device within about 3 meters of the wall, because you'll get reflections, and you could measure almost double the amount of noise, i.e. 3 dB higher, if you put that boundary noise meter in too close to the wall. So that's one of the reasons why you don't put these close to reflective surfaces. It depends on the courtyard. It might be, if it's a high wall courtyard, you put the noise monitor on the top of the wall somewhere, or where it's going over, so that so rather than it on the floor, because that's the noise that's leaving that courtyard. That might be a good idea for that, Anthony. So it is a question, but if it's a small courtyard, then it's could be a bit awkward. But if anybody needs any advice, then, and as I said, just please contact me. So I've rattled through a few questions. I'm really happy with the questions that have been given. Thank you very much for your thoughts on this. I hope this has been useful to you. Just a reminder that this is going to be available on our website to download and revisit at any time. I would say within the next week. But everybody that's been on here will get a link to this, and anybody that has signed up but wasn't able to attend, to get a link to it. But please, if you've got any further questions, or you'd like help, or if anybody would like some idea of the type of equipment that is available, you'd like to see what Cirrus has got, you're interested in our longer term quantum monitoring system and all the bits and pieces that go on there, or the handhelds or anything else, just please come back to me, and hopefully we'll be able to help you out. So thank you everybody once again. It's the last one of the year from Cirrus Research. It's something that we'll be starting again in the new year, a different set of topics. And again, if anybody has any ideas on what you'd like a topic on, that we haven't covered so far, or you'd like me to do something again, just let me know. Thank you very much.